My name is Dr. Sid Gunasekaran. I'm a faculty in the Department of Mechanical and Aerospace Engineering, and my specialization is in experimental aerodynamics. The problem started with a concept called spray drift. So you probably may have heard about farmers when they grow crops. They fill their tractors with chemicals. Those chemicals are pesticides and insecticides mixed with water, and then they spray across their entire field. The droplets coming out of the nozzle, it gets carried by the wind and gets deposited in an area where that chemical is not supposed to be. The EPA jumped in and they kind of created a strict protocols. Say you cannot use any nozzles or any chemicals. There is a certain combinations of chemicals and nozzles that you can use to minimize the spray drift. So you have this kind of Goldilocks zone where you want to make sure to get the droplet size just right. And that, it turns out, it's a very hard thing to do. If we can let an algorithm understand the differences between, hey, this is very coarse, this is very fine, this is medium, right? Then it will allow us real time in the field to put a camera right next to the nozzle, and based on the way it actually breaks up, right, based on the droplet distribution and everything, we can understand what is the drift potential.
I'm Bharat Narayanan, currently a research scientist at UDRI. I'm also an adjunct faculty with the ECE department. My expertise is in the field of machine learning, pattern recognition, and image processing. The algorithm perspective is that many currently machine learning and deep learning technologies have the ability to learn certain features and patterns, even complicated features which is difficult to spot through naked eye. My role here in this project is to develop such a technology which can identify the spray patterns and tell, hey, this is the nozzle it belongs to, or this is how much the spray drift is going to be.
So you can look at the pattern that comes out of it and understand, okay, just from this pattern alone, we predict that your drift is going to be this much. This literally affects the food we eat day to day, because the way farmers apply these chemicals, it really helps the crops grow better without contaminating the neighboring sources. The futuristic goal here is that, the way I have it in my mind, is that there is an app, right, that the farmers can use, that, hey, you put in what chemical combination, what the different nozzles and pressures, and you put the atmospheric conditions and all that, and then it'll tell you real time, hey, this is your drift potential.